Hello there, welcome to my question of the day, and this is number 31 in a series I've been running since the beginning of September on my Facebook page and on my YouTube channel. I tend to release them only on weekdays. I have the weekends off. I suggest you do too. Okay, this question today says, if the area of my field shown is 26 metres squared, what is the value of x correct to one decimal place? So I think the first thing I'm going to do is get my diagram really nice and big, and I'm just going to write down that fact that the area is going to be 26 metres squared. This question caused so much controversy yesterday when I released it on Facebook that if ever there was a reason to do a video, it is definitely a good reason to do for this question. Okay, now there are a number of ways that you can express the area of this field. Or a number of methods you could use in order to do that. You could, for example, break up this compound shape into a rectangle going down that way. You could split it again, so you have a central one, and you could have the one on the end. So you could find the area or expressions for the area of each of those three individual rectangles and add them together. Personally, I don't really want to do that. What I'm going to do instead is I'm going to say to you to consider if I actually had a big rectangle. And my big rectangle, I'm just going to highlight as all of it in yellow. My way is not necessarily the best way, it's just a way. If you're going to start saying what the best way to do something is, well, the answer is there are lots of best ways, I think. So I think the area of the large rectangle, the largest rectangle, is 5 times 6, which is going to be 30 metres squared. Now I can see that there's a little bit that I could then cut out. It's actually going to be this little white rectangle there. I could just cut out, and that would leave me with the area of my field. Okay, but what I really need to do is I need an expression for the height of that little rectangle. Well, I know that the vertical height is 5. I know that this shorter vertical height is x. I think that is 5 subtract x metres tall there. And if I want an expression for the width of that rectangle, well, I know that all the way across is 6 metres, and I've got to take away 2 lots of x. So 6 take away 2 lots of x metres is the length there. So I think what I'm going to do, therefore, is I'm going to find the area of this small white rectangle. And I'm going to find the area by doing 6 subtract 2x multiplied by 5 subtract x, which is 30 minus 6x minus 10x plus 2x squared. Just tidy that up. I've got 30 subtract 16x add 2x squared. Therefore, my yellow area, which is what I was given to start with, is going to be 26 metres squared. Aha, yes it is. But also my yellow area is going to be the large area subtract the area of the small white rectangle. So I actually have 2 ways of expressing the yellow area, which therefore implies that 26 must equal 30 subtract 30 minus 16x and 2x squared. So I have formed an equation. I've got to find out what the value of x is, so that's a good thing. I've got to be careful here because I've got 30 subtract 30, add 16x, subtract 2x squared, which is going to give me 26 is 16x subtract 2x squared. And those of you that recognise a quadratic where the highest power of x is 2 know that you have to make it equal to 0 to be able to solve. So I'm going to rearrange it, and I'm going to add 2x squared to both sides. I'm going to subtract 16x from both sides, and 26 is 0. I notice that I can divide everything by 2. So I've got x squared minus 8x add 13 is 0. And now I just want to solve that quadratic. And then we've got 3 ways of solving the quadratic. I could use the quadratic formula, I could try and factorise, or I could complete the square. Again, there are 3 different methods that I could use. My initial reaction is to never just reach for my calculator. I always like taking a longer circuitous route. But what I do notice is the coefficient of x. Whoops, the coefficient of x is, oh, whoa. What am I doing there? I'm not quite sure what's going on here. I notice that the coefficient of x is a even number there. So I think I'm going to complete the square. I'm doing this because I don't think that I can factorise using integers. So I've got x minus 4 squared. Now if I were to have that bracket squared out, I would get x squared minus 8x plus 16. I want to have plus 13, so I'm going to subtract 3. That is the equivalent expression of x squared minus 8x and 13. So therefore, that implies that x minus 4 squared must equal 3, and therefore x minus 4 must equal the square root of 3, but I know that there's 2 square roots of 3, a negative and a positive, and so x is equal to 4 plus or minus the square root of 3. Now, that's an exact answer. I'm very, very used to writing exact values. So therefore x is either 4 subtract root 3 or x is 4 add root 3. Either of those values of x will lead to an area of 26. However, let's just check what the decimal equivalents are, because it did say to find x to 1 decimal place. So typing that into my calculator, the first one gives me 2.3 to 1 decimal place. And the second one, I just type that in, gives me 5.7 to 1 decimal place. Now, neither of those values are negative, so it looks as if 2 answers are therefore possible. But I think it's always very useful to go back to our diagram, because I'm not sure that both of those are actually allowed here. If I go back to my original diagram, and I'm going to rub everything off, I want you to think about what would happen if x were, for example, 5.7. Now, I can see that x there, which is vertical, oh, hang on a minute, that has to be smaller than the vertical height of 5. 5.7 is definitely not going to be right there. So does x have to be less than 5? Or does x have to be less than something else? Well, I think the 2 horizontal lengths are interesting here, because I've got 2 lots of x there. Well, 2 lots of 5.7 is definitely not going to work. Absolutely not possible at all. But if I want to look upon limitations of what x could possibly be, what I'd really like to do, or what I'd need to do, is look at the horizontal length at the bottom, which is 6 metres. I know that there is a gap in between those 2 x's, but I think those values of x has to be less than 3. If they were both equal to 3, imagine what would happen. If they were both equal to 3, they would meet right in the middle, those lengths, which would mean there would not be a gap at all, and therefore that diagram would be inaccurate. I think x has to be less than 3. Because if x was less than 3, there would therefore be a gap. And so therefore, there is only one possible answer. X is 2.3 to 1 decimal place. I really enjoyed the controversy that this caused yesterday on my Facebook page, and I really enjoyed the discussion. And I think we have to remember when we're discussing answers that it's not really an argument. It's just an intellectual discourse, and I think that bad feelings should never arrive from just discussing why a particular answer is not allowed. Anyway, I really enjoyed that question. Thank you for bearing with me. I wonder if you got that right too, and I wonder which value of x you decided it would be. Thank you very much. If you've got any more comments, please leave them below on my YouTube channel or head over to my Facebook page. Thank you very much.